Hello friends, in this video I am going to discuss about the second example on the MOSFET as diode connected transistor. Okay, already in my previous video I have discussed the theory of the MOSFET as diode connected transistor in detail, and I have already shown you one numerical based on this concept. You can check the previous video from the link given in the description below. Okay, so now let us try to solve another example on that concept. See, here one circuit is given, and for this particular NMOS, see, this is nothing but diode connected transistor configuration, because gate is short circuited with the drain, and here this voltage, drain voltage, is nothing but VD, which is equal to the gate voltage also, right? This R is unknown to us. We are applying 3 volt here, and obviously here you can clearly see the source is grounded, and here the body terminal is not shown. That means body is basically grounded with the, body is basically short circuited with the source, right? So what are the given data? Let us try to observe. So I, that is current flowing through this resistor, is equal to 80 microampere. Okay, VT, that is threshold voltage for this particular NMOS, is 0.6 volt. Mu n into COX is nothing but 200 microampere per volt square. L, that is length of the channel, that is nothing but 0.8 micrometer. W is 4 micrometer. Lambda is given as 0. That means they want to say you that you should neglect the channel length modulation. Okay, so okay, that is fine. Now we have to calculate what is the value of the resistance and what is the value of the drain voltage VT. Okay, so now see what is the approach. Very simple. First, as we know I, we can easily calculate the drain voltage VD, because we know that this particular diode connected MOSFET is nothing but it always remains in saturation region, right? So we know the current expression, I is equal to half into mu n into COX into W by L into VGS minus VT whole square, and for this particular configuration VGS equal to VDS, right? So, and one more concept, you also know that this current which is flowing through the resistor R will flow through the drain only. No current will flow through the gate path. That is, observe the mouse pointer. Through this path no current will flow, because we know that is gate current is equal to 0 if we do not consider the hot electron effect or tunneling current effect. Okay, so here we no need to consider those nonlinear effects. Simply, as we know, gate current equal to 0. So this whole current will flow through the drain, that will come out of the source, because ID equal to IS for MOSFET, right? So basically let us try to calculate the VD. So MOSFET as diode connected transistor, so obviously MOSFET is in saturation region, so apply that formula, that is I equal to half into mu n into COX into W by L into VGS minus VT whole square, right? Now substitute the values. I is 80 microampere. See, here it is clearly given. Now half into mu n into COX is nothing but 200 microampere per volt square. I is microampere. Mu n into COX is also in terms of microampere per volt square. So micro will cancel. No need to think about 10 to the power minus 6 conversion. Okay, fine. Now W by L. W as 4 micrometer, L as 0.8 micrometer. Substitute that into VGS minus VT whole square. From here, by simplification, we can get VGS minus VT whole square as 0.16. So basically we can get VGS minus VT as 0.4. Okay, so VGS equal to 0.4 plus VT, and what is the threshold voltage value for this particular NMOS? That is 0.6 volt. Okay, fine, substitute that. So VGS you will get as 0.4 plus 0.6, which will equal to 1 volt. So VGS equal to 1 volt, and you know for the diode connected transistor configuration of MOSFET, VGS is equal to VDS. So substitute that and you will get VDS equal to 1 volt. Now see the circuit, very easy. VDS, that is VD minus VS equal to 1 volt, right? Now source is grounded, so VD equal to 1 volt, or drain voltage equal to 1 volt, we can say. So basically that's what I have written here, VDS equal to 1 volt, and as the source is grounded, we can say VD equal to 1 volt. Okay, so first of all we got what is the drain voltage. Another unknown parameter is the resistance. We have to calculate, that is the resistance of this. Very easy. just consider this part, that is apart from the NMOS, consider the upper portion of the circuit and draw it separately so that you can clearly understand what is happening. So 3 volt, then one resistor, then drain voltage VD, I current is flowing. You know what is the value of the I? I is nothing but 80 microampere, which is given in the question. VD just now we calculated, that is 1 volt. So R is equal to what? V by I. V is equal to IR from Ohm's law, right? You know. So R is equal to 3 volt minus VD or drain voltage divided by the current I, which is flowing through the resistor R. So R is equal to 3 minus VD by I. Substitute the values and you will get R is equal to 3 minus 1 volt by 80 microampere. 1 microampere equal to 10 to the power minus 6 ampere. So basically substitute that and simplify by calculator. You will get R as 25 kilo ohm. Okay, so this is how you should solve this type of numericals. Very easy. You should just keep this concept in your mind that when the gate is short circuited with the drain, then obviously the MOSFET will be in which mode? Saturation region, right? So basically what we are getting, the voltage, drain voltage VD is nothing but what? 1 volt and R is 25 kilo ohm, right? That's what we got, right? R is 25 kilo ohm. Fine. So this is all for this video. For more videos related to electronics and communication engineering, please subscribe my channel and don't forget to press the bell icon. And if this video is helpful for you, please like, share and comment. Thank you.